Alright, evening everybody. I just wanted to first off apologize for the low quality of this video. I know it's not the highest quality, but I just want to make sure that you'll bear with me a little bit, and I'll try to go through it a little bit quickly so that you guys can get rolling on what you need to do. So I just need to talk a bit more about putting your scripts together inside Unity and being able to succeed in building out algorithms. So, to go over what we had last week, essentially each item in our game has built within it several attributes that we can change, and how we choose to apply those changes through code makes our game. Our only constraint is the hardware we have to work with. So if you really consider what you have seen throughout video game history, that is essentially all at your fingertips right now at the moment. I want to really just underscore that you guys have the ability to, with time and energy, create absolutely anything, and I want you to have that mindset. So we talked a bit about where you guys can find further resources. The Unity documentation is obviously the first place you're going to want to check. Stack Overflow is another great site to help you find answers to all of your programming related questions. And under this heading, I see we've got, knowing what to search for online. And I think when you're searching for information on tasks you want to try to achieve within programming, you really want to understand exactly what terminology you're going to try to target when you're looking for information that you search for online. Paying attention to making sure that you design your scripts ahead of time to try to understand how you want those algorithms to work is important, but before you go out and try searching for information on them. If you try to search with really broad terms, you're not going to find a lot of quality information. But if you try to target that information using tight little searches to find out specific answers to really individualized questions, I think you'll be more successful in finding the resources you need. And looking for resources is something that every programmer will need to accomplish if they're going to be successful. Nobody can really realistically memorize all the documentation that's included within every programming language or every platform. But knowing how it's organized and knowing what questions you really want answered is going to help you find the answers to the questions you have more quickly. So to get into the nuts and bolts of programming, we talked last week about iteration, we talked about conditionals, and I want to go into just a bit more about loops right now. And within programming, we have a few different kinds of loops. This isn't an exhausted list of the types of loops you can use, but these are pretty much the most common. What we've got first is counted loops, and these are loops that iterate a list of code or a block of code a certain number of counted times that you specify beforehand. These are generally the most efficient loops that there are. When I write loops inside programming, I try to do counted loops as much as possible. I generally avoid while loops because they seem to use just slightly more resources. That doesn't mean that they're inappropriate for use. It's just that you can never get stuck in an infinite loop in a counted for loop. So that just takes a big no-no of programming away from you if you try to constrain yourself to not use while loops while they exist. The third kind of loop that we can go into is recursion. So let's say I declare a function, and then inside that function itself, I call that function. Let's say I name my function foo, and then inside that function I call foo again. That's going to put me into recursive iteration. So what's going to be happening there is that function, because during its execution it calls itself, it is going to continue to iterate over and over and over and over until you find a way to break out of it with a conditional or by returning a value before you get to that call once you've reached the point in that code you want. Within Unity, generally speaking, you don't have to use a lot of loops. In regular standalone programming, you might need to iterate something several times. But within Unity, because we have update calling on every frame, that's generally going to do the job we want if we want to do something that might require a loop. Now, that's not entirely true. There are times in which you'll want to use loops, and there's actually times in this presentation where loops will become appropriate, and you'll see where that is once I get there. But if you decide within start or update or the other functions that also update, fixed update and late update, which you can look up, fixed update, late update, you will find that if you, say, try to move a box inside a loop that you've written, if you want to move a cube 10 meters and you want to do it 1 meter at a time, you're not going to want to try to do that inside a loop. The loop inside update will execute in its entirety before the next update. So loops inside of the standard Unity calls are generally unnecessary unless you need to modify, say, all of the materials that might be applied to a single object. You need to iterate through every single one of those materials to make a change to them. So this kind of brings another point. You know, in gaming, timing is important. When we're working inside a game and when we're telling stories, the timing of a story can be pretty important. The timing of how events chain and happen within a sort of not programming script, but in the written script of a game interaction, the timing of those interactions can be key. So say you like I've got here, if you shoot an enemy in an RPG, the number of damage might appear above his head for a few seconds. Inside Unity, because we have that frame-to-frame count running all of the time, we'll need the ability to run timers that sort of sit outside of the start and frame-by-frame paradigm. We need a timer to run independent of the rest of the game code. And that is achievable. And we'll go into how that works. What the programming methods that we're relying on for timing, and this isn't something that's required for you to learn right now. This is very much something I want to make sure that I convey to you, that this is a terminology you can go look up to find more information for yourselves. So you might want to write this down, coroutines. So let's say I want to run a 2-second timer for some sort of interaction within my game that can't run inside update. Reason being, we all want our game to run at 60 frames per second, but that doesn't mean if we want an action to take 2 seconds, we just count 120 frames and then iterate our 2-second change. Timing is going to be soft. It's not going to be the same from machine to machine. Update may call anywhere between 10 frames per second and 200 frames per second. So we need the ability to do those timers outside of the start and outside of update. And what you'll use then is a coroutine, which is essentially a function that's going to run on another processing core. It's going to set itself up on a separate thread that it can then do the timing that you want and give information back to your script. So save this one for a rainy day. Tuck this, whatever. Put this in your backpack so you can remember it later. Coroutines are going to help you time out functions that require precise timing. So I also need to talk a bit more about logic in how it pertains to conditionals. We might set one single true or false variable and then test it inside of an if-else conditional statement. But what if we have several different things we need to account for inside our logic? And don't be fooled that logic might be simple. It can actually get quite complex. There is an entire field of philosophy for logic. So I wanted to get a little bit into operators. Operators inside programming code are symbols that you use to delineate, especially in the case of logic. We're going to use these operator symbols to help make sense out of the code that we've got and make some sense to the compiler. So take this conditional we've got right here. if, let's say, I'm after some candy. So let's say I've got this condition here. If I like candy, and then inside the like candy block, I have another conditional that says if the candy is free, then I'm going to execute my function, whereas I am going to eat some free candy. Now, this is perfectly logical. This is acceptable programming. You can nest your if operations inside each other. But once you get beyond, say, 2 or 3 different conditions, nesting conditionals can start to get pretty unwieldy, and they can become very difficult to read. So we need the ability to determine if, say, 2 statements are true. We can also write out our 3 different conditions. Well, actually, this is 2 different conditions in a single line using this ampersand, ampersand, and operator. This line basically says, if I like candy and I have more money than the price of that candy, then I can eat some candy. I don't even think it doesn't make sense that I would eat free candy if it costs money. Let me get rid of that. I'm just going to eat some candy that I've paid for. Now, this side of the condition is a single Boolean variable. This is either true or false. But on this side, I've got probably some float number values. I've got my money, which I would assume is some amount of money, and then candy price, which is how much the candy costs. I'm just using the standard mathematical greater than symbol. If my money is greater than candy price, that statement itself is either going to evaluate to true or false. Because this is an AND operator, both of these statements here must be true. So to be more explicit in what this means, I can wrap this side of the condition in parentheses so that I can more easily read that this is a condition that's being tested and this is a condition that's being tested. Both of these must be true before I can eat candy. Another type of operator we have is the OR operator. Now, this will progress if you have an OR operator inside of an if statement. Either one of the statements must evaluate to true. But if they're both false, then the function's not going to be executed. If they're both true, then they will obviously still both be executed because only one must be true. So take, for example, this statement here. If I like candy, and either candy is free or I have more money than the price of that candy, then I'm going to buy that candy and I'm going to eat that candy. So, as we can see right here, this itself is a statement. And inside this statement, I have another statement. This itself is a little statement that will either evaluate to true or false. So I can wrap that right there. I like candy, and the candy's either free or I have enough money to pay for it, then I can buy it. Then the other common one we've got here is the NOT operator. The NOT operator essentially, makes it evaluates as to whether or not the statement you've provided will be false. So if I don't like candy, then I can save some money. Basically what this block is going to do is it's going to say if I don't like candy or if I like candy is false, then we're going to run the save money method. And we should get into how these parenthetical operations are going to evaluate. The parentheses that you're going to use, and I do recommend that you wrap any statement that can evaluate as true or false in parentheses, even if it's just one and you're doing 2 conditions. This is not overkill to just have I like candy be wrapped in its own parentheses. We can see here, though, that this statement here is fundamentally different from this statement here. What I have here is this condition, I like candy and candy is free, or my money is greater than the price. One of these statements must be true. It's not exactly the same as I like candy and candy is free, or I have enough money to pay for it. Within the first statement here, I like this candy and it's free, or I have enough money to pay for it, doesn't really take into account whether or not I actually like the candy. You have to be really careful when you're writing if conditionals. This is pretty obvious stuff, but you'll probably get into some more complex territory where you're going to want to make sure that you're evaluating things correctly. Always test these out. Use print statements to make sure that the data is coming out the way you expect it to. Test these variables, test these conditionals to make sure that whatever data you throw into it is going to be true. Or false, if that's what you're designing it to do. Another important feature that every program must have is, let's say we've got several components, and the data on those components might affect the data on each other. How do we get that information from one object to another? So in our homework from last week, well, it's actually is due this week, we had one script that was our character firing up a pill-like projectile, and when it crashed into the cylinder, after I think 10 hits, it destroyed the cylinder, or at least just made it delete itself. Or, spoiler alert, if you didn't do the homework. Let's say we have 5 or 6 different kinds of bullets. Let's say we have, the iron bullet, the silver bullet, the lead bullet, the gold bullet, and they all have a different damage amount assigned to them. We could technically tell that cylinder to detect what kind of projectile it's been shot by and then apply a certain amount of damage depending on what kind of bullet it's been shot by. So inside our on-component update, we could say, if I've been shot by the gold bullet, take 30 damage. If I've been shot by the silver bullet, take 15 damage. If I've been shot by the iron bullet, take 10 damage. And so on and so on and so on. I think that probably would get pretty unwieldy, especially if you're making a role-player game where you might have, dozens of different kinds of bullets. So let's say maybe it would be just a bit cleaner if we held the damage amount inside the bullet itself. But we want to get that information from the amount of damage that the bullet is going to impart on the cylinder to the cylinder itself so that it understands how much damage it's taking. And what we're going to do is we're going to write that damage amount into a component on the pill. And that component will transmit that information to the cylinder. So I've written a script inside the same homework repository from last week, and I want you to go ahead and take a look at that at your leisure so that you can see that the pill is now imparting that damage onto the cylinder. It's transmitting that information so that you don't have to try to store dozens of different kinds of conditionals inside the collision that happens on the cylinder. The cylinder can just find out for itself how much damage it needs to take from the projectile. So you can look at those examples on the sample project. I do believe I've written in a coroutine as well so that you can see how a timer might operate. Feel free to steal any of that code, use it for yourselves, and see how that's going to work for you. So for the rest of class today, I do have a mission for you. So I'm going to leave this up, or you guys can just write it down. But I want you guys to group up into your groups, and if you're working by yourself, I suppose you have the option of either flying solo or tagging onto a group. This isn't necessarily a project I want you to turn in, but I do want you to work on it, see if you can't figure it out. It's rather simple. You might just discover the end of it more quickly than you think. So essentially, within my house here, I have a hall light, as you can read, and if I switch one switch on at one end of the room, it's going to either turn on or off the light. But if I walk across the room and flip the other switch, it's going to turn on or off the light as well. This first switch isn't going to change position. It's either going to stay up or down. You've probably got a light switch like that somewhere in your house. Essentially, I want you to make that happen. I want you to use conditionals. I want you to tell that light to turn on or off depending on the value of some booleans that live inside the switches. So a switch can either tell the light that it's on or off, and the light is going to have to figure out how to evaluate whether it should be on or off depending on the position of those switches. So good luck with that, and I hope this has been informational. You can email me anytime you want, but hopefully this has been helpful, and I realize I'm sort of stumbling over myself as I talk. That's just sort of how I work. But good luck, and I will see you guys next week.